Pluto, once considered a distant and puzzling minor planet, was originally classified as a member of our solar system's planet group. However, groundbreaking revelations from prominent astrophysicists such as Neil deGrasse Tyson and Michio Kaku have thrust Pluto back into the spotlight. They shared a surprising theory suggesting that Pluto could be on a collision course with Neptune. But how is this possible, and what could the consequences of such a cosmic collision be? Are we witnessing a rare cosmic event, or is there something more to this impending catastrophe? Join us as we explore the potential outcomes of a Pluto-Neptune collision. Once regarded as a full-fledged planet, but later demoted to a dwarf planet due to its peculiar orbit, Pluto remains an object of intense interest and study in the scientific community. Recent forecasts from leading researchers indicate that Pluto's orbit is dangerously close to that of Neptune's, prompting astrophysicists Neil deGrasse Tyson and Michio Kaku to raise alarms about the potential for a catastrophic collision between these two celestial bodies, a scenario that could pose a significant threat to Earth. But how can this even be possible? Pluto's journey around the Sun is unlike that of any other planet in our solar system, taking an astonishing 248 years to complete a single orbit. Since its discovery in 1930, it has yet to finish even one complete revolution. Yet Pluto's orbital eccentricity doesn't end there. Its orbit is highly elliptical, starkly contrasting with the nearly circular paths of the other planets. Adding another layer of peculiarity is the angle of inclination of Pluto's orbit, calculated to be 17 degrees to the ecliptic plane. This means Pluto's path is much steeper compared to that of the other planets. The combination of eccentricity and steep inclination makes Pluto's orbit a complex puzzle. Perhaps the most intriguing aspect of Pluto's orbit is its interaction with Neptune's. For approximately 20 years in each orbit, Pluto comes closer to the Sun than Neptune. This contradicts what we might expect from their relative positions in the solar system. Naturally, this prompts the question, why hasn't Pluto collided with Neptune? The answer lies in the gravitational influence of other planets. Pluto's unique orbital behavior was first examined shortly after its discovery. Astronomers were initially puzzled by its unusual trajectory. Unlike other planets whose orbits lie relatively close to the ecliptic plane, Pluto's path is tilted and elliptical. The mystery deepened when it was realized that Pluto's orbit does indeed cross Neptune's path. The fact that Pluto's orbit remains stable despite these apparent conflicts demonstrates the intricacies of celestial mechanics. The study of this phenomenon involves the three-body problem, which seeks to understand the gravitational interactions between three bodies in space such as Pluto, Neptune, and the Sun. This is akin to predicting the movements of these bodies based on their starting positions and the gravitational forces they exert on one another. In Pluto's case, this issue highlights how Pluto's orbit, Neptune's path, and the Sun's gravity work together in a complex manner. Terms like asymptotic libration, scope libration, and the VSK oscillation help explain this. Astrophysicists have determined that the phenomenon of libration is crucial in maintaining orbital stability between Pluto and Neptune. Libration ensures that when Pluto crosses Neptune's orbit, their relative positions are always at least 90 degrees apart, preventing a collision. Scope libration describes the vertical movement of a celestial body in its orbit. For Pluto, this means that when it comes closest to Neptune or any other large planet, it is positioned above their orbital plane, offering additional protection from a potential impact. Another key factor in maintaining Pluto's stability is the VSK oscillation, named after researchers V. Appel LV and K.I., who studied the gravitational effects between three objects in space. This concept explains how Pluto's, Neptune's, and the Sun's gravitational interactions influence Pluto's orbit. The VSK oscillation helps us understand why Pluto's path around the Sun is so unusual and, despite appearing chaotic, actually helps maintain Pluto's orbit for an incredibly long period. This oscillation shows that even in seemingly chaotic systems, there are underlying patterns that help maintain stability. All these components, libration, scope libration, and the VSK oscillation, help ensure that Pluto's orbit remains stable, preventing a collision with Neptune. This interplay of forces demonstrates how complex celestial mechanics can stabilize even the most seemingly erratic paths. The role of other planets. Understanding the three-body problem is essential for unraveling the dynamics of these orbits, not just for Pluto but also for other distant objects in our solar system. Mathematical simulations from the late 1980s revealed that while Pluto's orbit is stable for now, it does exhibit minor variations that could lead to significant changes over millions of years. These simulations also demonstrated how the gravitational forces of giant planets like Neptune, Jupiter, and Saturn contribute to stabilizing Pluto's path. In fact, Pluto has a unique relationship with Neptune where Pluto completes 2 orbits around the Sun for every 3 orbits Neptune makes. This resonance helps maintain the stability of Pluto's orbit. However, Neptune isn't the only planet influencing Pluto's path. Jupiter, with its massive gravitational pull, also plays a vital role in protecting Pluto's orbit. Saturn's influence further contributes to this cosmic stability. Simulations indicate that Jupiter alone has enough gravitational force to keep Pluto's orbit steady over incredibly long timescales, possibly billions of years. It's as though Neptune, Jupiter, and Saturn are working together to prevent Pluto from encountering any dangers in space. The role of the Sun. In addition to the gravitational forces exerted by the planets, the Sun's gravity remains the most fundamental force guiding the trajectories of all objects within the solar system, including Pluto and Neptune. The Sun's pull establishes the general structure of planetary orbits and the overarching stability of the entire solar system. However, the Sun itself is far from static. It undergoes various cycles of activity such as solar flares and fluctuations in its magnetic field. These changes, while subtle over short periods, could influence the orbits of distant bodies like Pluto and may over incredibly long time scales alter how Pluto and Neptune interact with one another in the far future. The future of Pluto's orbit. Although Pluto is safe from a direct collision with Neptune at this moment, the dynamic nature of the solar system means that no orbit is permanently fixed. There are forces beyond gravity that can influence the motion of celestial bodies, and even tiny disturbances in planetary orbits could lead to larger changes down the road. This chaotic motion is one of the defining characteristics of the universe, constantly evolving, shifting, and presenting new challenges for astronomers to decode. While a Pluto-Neptune collision is highly unlikely in the immediate future, it highlights the inherent unpredictability of stable systems over long periods. Computer simulations have shown that even minor changes in initial conditions can have significant effects on Pluto's future path. These small adjustments, when compounded over millions or even billions of years, could potentially bring Pluto closer to Neptune's orbit. This raises interesting questions. Could other dwarf planets or objects beyond Neptune experience similar gravitational encounters with larger planets like Neptune or even Jupiter? Conclusion. While Pluto's orbit is expected to remain stable for the foreseeable future, the possibility of change driven by chaotic forces within the universe cannot be discounted. The study of Pluto's trajectory offers valuable lessons not only about the current state of our solar system, but also about the mechanisms that may shape its evolution. By continuing to study Pluto and its interactions with Neptune, researchers gain a clearer understanding of the broader forces at play and how these forces might affect the solar system in the distant future. Pluto's path through the cosmos is far from simple. Despite its current stability, it offers a remarkable example of the intricacies of celestial mechanics and the forces that govern planetary movements. The delicate cosmic dance between planets like Neptune and Pluto emphasizes the sheer complexity and wonder of the universe. Even though Pluto's orbit may remain steady for the foreseeable future, there is always the possibility of change hidden within the chaotic forces of space.